what's up guys, after Unit 15, which is about file I/O, reading and sometimes writing, we have a little project called Bank Account that I created to test those skills. So part 1 says, here's a file with the activity for a bank account. They might deposit and then a number, or withdraw and then a number. And assuming they start at 1,000, how do we end up? If you start at 1,000, deposit 100, and then withdraw 500, then you end up with 6, you know? So let's see. We have just word, number, all the way down the line. And we're going to use, the way that they do it in Unit 15 is open the file and close. We're going to learn another way called Context Manager that's just a little bit nicer, but this is what they introduce in Unit 15. And you could say, for example, f.readLine, just to read one line and see if we're doing it right. Okay, so that's the top line. Great. And what I want to do is get it into a usable form, which probably is going to involve turning the deposits into positive number and turning the withdrawal into negative number. In this case, I'm going to make a little function to handle that. Whenever you have a function that takes a string and turns it into something more meaningful, we usually call that parse, P-A-R-S-E. That's just a word, not a computer word, but it's been around forever. That means, you know, you look at a sentence and you go, oh, that's the subject and that's the verb or whatever. So let's do this. What I'd like to do is to say dot replace deposit with plus and withdraw with minus, and then we turn that to an int. However, it's space, so we're going to go deposit space becomes a plus. You could also split and then say, like, if the word was deposit, int the number, and if it was withdraw, int negative, whatever. And then you could say dot replace again, withdraw, space, negative. And now it's getting long, so you can put those as their own line, which is usually easier to read. And so let's say, you know, numbers, we'll just call it numbers. And then you can say print numbers. Now, this could be right, or it could be a typo that I need to fix. It looks good. So we got 7, 1050, 7, and then we have a negative 825. So let's see if that matches with the file. Yeah, the first one that is a withdraw is 825. So guess what? We're done. We can just add them up, and that's pretty much it. You might say, like, okay, let's make a main file to make it really nice and organized. And then we'll say, like, okay, starting balance is 1,000, final balance is starting plus sum of numbers. Now, numbers is a silly name for it. We could call it something better. Delta, like the change, you know, the up or down. And then print final balance. I believe it's going to be 7,000 something if I remember right. Yeah, there we go. Part 1, done. The reason why it was simple is because the order doesn't matter. When you add numbers, it doesn't matter if you do them, you know, all the positives and then all the negatives, or if you separated them or whatever. That's what we call the commutative property. And the associative, I guess, is involved too. But part 2 is where it gets interesting. we say, what if the transactions sometimes undo? They're like, oh, we're going to withdraw, never mind, cancel that. We're going to withdraw a different amount instead. And this is what happens a lot in real life. If you had a log of like the buttons I press, well, some of them I would undo, and they're not all in the final version. So we still have deposit, we still have withdraw, but we can't just add them up because we have the undo, which is like, hey, take the last one off, or 2 or 3. Sometimes we give it a number. So I wrote this, I wrote the hint. You can use the pop method to take off the last one, the one on top, if you think of it as a stack. So let's copy this because it's kind of the same, but the activity is different. You'll say, hey, we deposit, withdraw, and then oops, undo that last one, and then oops, undo the last 2. But if there's another undo, like right here, we do these 2, and then this 3 doesn't cancel the 3 lines above it. It cancels 3 deeper than we had already gone. So it's like you take it off the stack, and then you take whatever is now on top. And yes, that would be an error if we removed so many that it was empty, but that doesn't happen. So let's do it. Unfortunately, I can't return a number anymore from my first round of parsing the file. I have to return something that can be used in the second step. So, okay, can't do that. And we're not able to call it, I'm going to call it transactions. This will be like deposit 100, withdraw this, undo 1, okay? So this, not going to work, but we'll get there. So I'm going to go action amount equals line dot split. I think we should probably put a dot strip in there. You know, we got lucky last time when we didn't take the new line character off of the end. Apparently the int was okay with that, but I'm going to take it off just to be complete. And then action is a string, but amount is going to be turned into an int. So like, hey, withdraw 750, that's 1 string and 1 integer. Undo 1, that's a string and an integer, so they're not the same type. And now you could say, just as a little test, let's print, you know, the first 5 or something. There we go. They're tuples with a string and an int. Nice. Now, though, we need to look through and say, oh, if I hit an undo, then I take off the most recent from the stack. And I'm going to make a little function for that because it's a little bit kind of a separate idea. It feels like a separate process. We put it through. And then we'll say, you know, do the sum again. So I'm just going to call it process, which is extremely vague, but maybe we'll think of a better name. And whenever we talk about this kind of idea in this kind of program, we usually call it a stack. So like if I do actions in a text editor and I like hit Control Z to undo, it's taking them off of a stack, you know? Or if I have tasks that need to be done and then I do the most recent ones, it always reminds me of washing dishes. Like if there's a stack of plates and I take the top one and I wash it, I take the one under that and I wash it, and then somebody else comes and adds more. Well, now I'm going to grab those. I'm not going to grab from the middle of the stack. I'm always going to be getting to the last one last, or the one that was first is last out. So you could say, okay, stack is a list, and then for, I'm going to say action amount in transactions because they're already separated in tuples, which is why this part was so nice, because now we don't have to do that anymore. It's already done. We already trust that it's a, you know, a word and a number. You could just do some if-else. You could do some other stuff if you like, but this will be fine. I'm going to say elif for the undo, even though we could say else because it's the third possibility. It just feels weird to not mention it, you know. You could say else. You know, I'm going to say raise value error transaction not recognized or something. Now, if that happens, that means we made a mistake, right? But that is possible, so why not? In fact, let's try it. Now this won't calculate, it won't come up with the right answer, but it will ensure, if I run this right now and I get an error, that means there was something in there that I didn't expect, and if there's not an error, that means there wasn't. Great, there wasn't. So that means this is kind of a security guard that doesn't stop any burglars, but is still there, so why not? Okay, so if it's a deposit, then the stack is going to get amount as a thing to be added, but not yet, because we might remove it. And then if it's a withdraw, the stack is going to get negative amount as a thing to be subtracted, but not yet, because it might get undone. And if it's undo, then we're going to go stack dot pop to remove one. Now that returns, and you could say something equals stack dot pop, but right now we don't need it because we're throwing it away. And the undo could be an amount, so I'm going to go for blank in range amount stack dot pop. Okay, so now we're going to go. We could do the sum now, where we could just return transactions of like, okay, this step is just to process the undos. And then we actually do the same thing now as we did in the first round, because now we've cleaned it up. But let's see what the length is, because there's 100 before this, and let's see how many undos there are. There are 12, but some of them might be 2 or 3, so it's going to be 12 for those lines themselves, plus 12 more for the ones they undo, plus some more. So it's going to be like 20, 30-ish, less than 100. So if it's like 60, 70, we're in the right track. This was created randomly, by the way. Uh-oh. Typed the wrong thing here. This was created randomly, by the way. I wrote a couple lines to say pick deposit 50%, withdraw 40% of the time, and undo 10% of the time, and then a random number, you know, according to certain rules. And 65, which means those guys on average were doing like 2-ish undos. So that's good. Now let's do the same thing we did. In fact, it might even be the same. Yeah, well. Oh, I can call this deltas now, because that's what it is. It's like just the numbers instead of the meaningful word number combo thing, right? And now I can say there you go. It's pretty close, because on average we're canceling out about the same deposits as withdrawals, but it's not the same. And we saw that the survivors after all the undos was only 65 instead of 100. So this process looks right, but let's prove it. Let's make it obvious to ourselves. Let's do one final step where we actually say print the stack, and then if you just say input, you pause for a second for, wait for enter. And so what I mean is this, it'll say like, here's the stack, then we add one, we add one, we add one, and then we undo. So like, let's see if this 950 got undone. Exactly. So now you can see visually what's happening is like the stack is growing. I mean, it's going sideways instead of up like a physical stack. And then it gets shrunk when it gets popped off. So that is the kind of thing that helps you visualize what's happening, and so it's nice to do. But our answer is this, and yeah, it took a little more work than part one, but it got us to think about it, and this is the kind of thing that sometimes happens when you read a file or you deal with data that isn't quite so easy as just saying, hey, do the sum, do the max, do the min, do the sort, you know? It's a good one. Thanks.